Welcome to the notes for 10.5. We got trigonometry and area. So we're going to use regular polygons again. So the formula that we had for that was 1/2 ASN, where we needed the apothem, the side length, and the number of sides. And then we are going to add in a little bit of review. We're going to use trigonometry for some of those, which is SOHCAHTOA. So we might have to do a little bit of review just to make sure we remember what that is. So that's what we're going to talk about. Everything's going to be 1/2 ASN again. It's just that the angle measures don't give us 30, 60, 90 triangles or 45, 45, 90 anymore. So if we have a missing apothem or something like that, or a missing side length, then that's when we might have to bring SOHCAHTOA back into it. All right, so here's a good example right away. All right, when we have a nonagon this time with 10 centimeter sides, we're going to try to find the area of that. So if we look right over here, nonagon is going to mean that we have 9 sides. So remember our formula, 1/2 ASN. And then this time we know that S is 10. We know that N is 9 since we have a nonagon. All right. What we don't know this time is the apothem, the length of A. We're not quite sure what that is. So to deal with that, what we're going to do is figure out how many degrees one of these angles would be. All right, and remember what we did for that was 360 degrees divided by how many sides we have. So what we have here are 40-degree angles. Okay, but as you can see down in the triangle here that they had drawn separate for us. All right, they represent it as a 20 because remember that apothem is going to cut the 40-degree angle right in half. All right, so with shapes that aren't hexagons or triangles, we end up with triangles when we do this apothem that are not going to be special right triangles that have shortcuts. So now we have to find this apothem to be able to find the area of this nonagon. So right now we have to find what this missing length is. All right, we have to try to figure out how long that is in centimeters. So that's what we're going to try to do. And the way that we can do that is with SOHCAHTOA then. So what we used to do, we find the angle that we have, we label what is the hypotenuse, what side is opposite, and what side is adjacent. And we use that SOHCAHTOA to decide what we should use as far as sine, cosine, or tangent. So we don't have anything over here by the hypotenuse this time. So we're left with O and A, which means we're going to use tangent. So here's a little bit of review on how that worked. So what we need to do to find A is take the tangent of 20 degrees. All right. The tangent of 20 is equal to the ratio of the opposite side over the adjacent side, like TOA, O over A. So we need to put 5 as our opposite side over A, which is our adjacent side. So that's going to be our setup. We need to go and try to find A from that. What happens when A is on the bottom like that is that we have a dividing problem. So what we need to do is multiply both sides by A, divide both sides by tangent of 20. What we end up with, A is going to switch spots with that tangent of 20, and that's where we can go to the calculator. All right, when the letter that you're looking for is on the bottom, it's going to be a dividing problem. So 5 divided by tangent of 20 gives you about 13.74 centimeters. So that's our apothem. So now we have that length. What we need to do with that is go back and get the area with that. So I know that if I go back up here, I just found that this is 13.74. Now I'm ready to plug in all of my numbers into the formula for the area of a regular polygon. So 13.74, 10 is the side length, and then 9 for how many sides we have. When you plug all that in, it doesn't tell us how to round, so I'm going to go nearest tenth this time. 618.3 square centimeters would be a good answer for that. So now the difference between 10.3 and 10.5 is you have to remember SOHCAHTOA. So we'll do a few more examples of that, and then there's kind of another formula that I'll show you today for a specific triangle situation that you'll see. All right, so let's try another one just like that. Let's see, what is the area of this regular pentagon with 4-inch sides? All All right, so area of a regular pentagon, that means n is 5. Sides are 4, that means s equals 4. So again, we are just missing the apothem. So we know the side lengths are 4, and we know there are 5 sides. So what we need to find is the apothem. So with a pentagon, there's my apothem that I don't know. I want to figure that out. I know that this bottom side is 4 total, but I'm going to think about it as 2 and 2. And then I got to figure out what angle I'm working with. I have a 2 and an A. I got to figure out what this angle is, so I know what angle to put in when I go to my SOHCAHTOA step. So to figure out how many degrees that angle is here, it would be 360 divided by 5 for 5 sides, or 72 degrees. So each angle in the center this time is 72, meaning I end up with a 36 once the apothem is drawn in. So that's going to be the triangle I'm working with this time. All right, this ends up being another tangent problem. From my 36, I have the opposite side and the adjacent side. I do not have anything for the hypotenuse. So again, with SOHCAHTOA, I'm going to use O and A and choose tangent. So to find my apothem, I'm going to take the tangent of 36 this time, set it equal to opposite over adjacent. I'm looking for that apothem, so a lot of times that's going to be on the bottom, which means we have a dividing problem once again. So this is going to be rewritten as A equals 2 over tangent of 36, meaning we can go straight to the calculator with that part, and we get about 2.75 for the apothem. All right, so that's going to be what I'm going to use for A this time, and then I'm ready to go and find the final answer. So let me do that right below here. So we have 1/2 of 2.75. They gave us the side length of 4 and the number of sides, which is 5. So after the calculator step, we're at about 27.5 square inches. They did say round to the nearest square inch, so we are going to round that up since it's closer to 28 than it is 27. Okay. We're going to try a few more, but now the difference is we might not know a couple things. So we might not know the side or the apothem, and then that's what we got to deal with. Okay. So real quickly, let's look at something like that. All right, so this one is a stop sign. Stop signs are octagons. They have 8 sides. The standard size has a 16.2-inch radius, so they did not give us exactly what we were hoping for this time, because they gave us a radius, meaning they gave us a hypotenuse of a right triangle. So that they gave us 16.2 being a radius this time. They want to know the area of the stop sign to the nearest square inch. So I don't know the apothem. I don't know the side length. All I know is I have 8 sides so far. So I need to do a couple steps to figure out A and S, so that way I can decide what numbers to go into the formula. So a couple steps now. They set some things up for us already. They kind of set us up with this triangle with the apothem here and part of the side length here. Remember, the side length is going to be twice as long as whatever that little x is on the bottom there. So we have 2 things to find. They gave us a 22.5 right there. All right, that came from 360 over 8, giving us 45-degree angles, and then cutting that in half to get that 22.5. So they put that right in the picture for us already. So one less step. So let's get to the trig stuff. All right, if we want to find the apothem first, that would be the adjacent side, and what we also know is the hypotenuse this time. So A and H, O is going to be on the bottom this time. A and H would give us the apothem, so cosine is the one that uses A over H. So we're going to use cosine of 22.5, set it equal to the adjacent side, which is A, which is the apothem, what I want, over 16.2, which is the hypotenuse length, the radius that they gave us. When the number's on the bottom, we just multiply both sides by 16.2. All right, and we can go to the calculator for this step. 16.2 times cosine of 22.5. When you punch that in, you end up with about 14.97. So that's the apothem. We have that one figured out. We have to also get the side length. So I'm going to use, to find x down here, it's the opposite side in the hypotenuse. O and H go with sine. So sine of 22.5 will give us the half of the side length. It'll give us x. X over 16.2. When I multiply both sides by 16.2, I get what needs to go in the calculator. So x is going to be 16.2 times sine of 22.5. Okay, one thing I forgot to mention is to make sure you are in degree mode for these. But 16.2 times sine of 22.5 gives us about 6.2. All right, just remember that that's only half of the side length. So we need to take that and double it, multiply by 2 to get what S is. S is going to be twice as long as that 6.2, or about 12.4. So now I have everything I need, and it's time to get the final answer. Okay, so I'm going to continue a little bit below here. To get that final answer, we're ready for the formula, 1/2 ASN. A we figured out was 14.97, S is 12.4, and N is 8. When I punch all of that in, again, we're doing nearest square inch, I get about 742.5 square inches, which is going to round up to 743 square inches. So on that problem, we were missing two things. It was a sine step and a cosine step. Remember when you find the bottom part or the side, the x, that's only half of the side length that you end up wanting. So the next one we're going to do is going to be the same couple steps. I would recommend pausing it and trying it, just so that you get a chance to make sure you're doing it correctly. It's set up the same way. So what I would do is we can go through the setup together, and then you would click pause and try to solve. All right? I think that would be your best course of action here. So last one like this, and then I got to show you a formula that happens sometimes with triangles. So they gave us a decagon this time, and again, they gave us a radius. So they gave us something that we don't want. So we don't have A or S. They gave us R. We do know that N is 10 because they said decagon. They want the area of the table to the nearest square inch. So we can draw the picture here, and then I would say you should pause it at that point. Okay? They gave us a radius, which is 9.5 inches. All right, and they didn't give us much else, so that's what we got to deal with here. We have to find A, and we have to find X, and then remember we have to double that to get that side length. Okay, so I would start now with finding the angle. Try to figure out how many degrees that top angle would be, so you know what you should use for SOHCAHTOA. All right, but I'd look back at the previous problem and then look at this one. And try to work this all the way through. All right, I would pause now and then resume when you think you have a good answer. Go ahead and pause. All right, real quickly here to see how you did. What we would have had to do first is take that 360 divided by 10 to figure out how many degrees. Sorry about that. How many degrees we would have for an entire central angle. This time we're talking about 36 degrees. So you should have had that 36 get cut into an 18. So you should have been using 18 for all of your sine, cosine, tangent, whatever you decided to use this time. All right, we're missing two things. To find A, we're using the adjacent side and the hypotenuse. To find X, we're using the opposite side and the hypotenuse. So again, if we want to find the apothem first, cosine of 18 would have given us, let's see, A over 9.5 this time, all right, which would have given us 9.5 times the cosine of 18 for our calculator step. So A, you should have gotten about 9.04. All right, so that's that part of our list. For S, then we would have used the sine. We have our opposite side in our hypotenuse. So the sine of 18 would give us x over 9.5. Multiply both sides by 9.5. All right, and then what we end up with for x in that instance is we get 2.935 for x. All right, but remember that we have to take that and multiply by 2 to get the side length. So we get about 5.87 for s then. So then we have everything we need once more. We have 9.04 for the apothem, 5.87 for the side length. So once you had those two, you were ready to go to the formula for it. And if you haven't made a mistake yet from when you tried it before you paused it, then hopefully you got the correct answer. It was just calculator work at that point. What we would have got out is about 265.32 square inches to the nearest square inch. That would be rounding down to about 265 square inches. So you'll either be missing the apothem or the apothem and the side length. All right, so you'll either have one step of trig or two. All right, but those are going to be some problems that you might have to deal with on the worksheet for today. So one last idea, should be pretty quick. For sometimes triangles you don't have the height and you need to be able to figure out how to get the area still. Because we know that the formula for a triangle is 1/2 base times height, or base times height over 2. All right? Sometimes you don't know the height. Sometimes you don't know how tall it is. So in some situations you might know an angle, like how many degrees one of the angles are. You might know the base, but you just don't know how tall. But maybe you know the side that would include that angle that you have. So maybe you have side, angle, side on a triangle. And when you have side, angle, side on a triangle, we could come up with a formula to find the area of that triangle, because we always end up using the same trig ratio for that situation. If I know this side, this is like the hypotenuse of a right triangle. As soon as I draw the height in, I have a right triangle, right? So it doesn't matter. I don't know how long this part is, but that's okay. What I want to figure out is this height, which is going to be the opposite side. So if I know C and I'm looking for H, I always will have this angle, the opposite side, and the hypotenuse. So this is always going to be a sine problem. Sine of whatever angle A is going to give me that height I want over C. If I know what that number C is, then I can always just take and multiply both sides by C. What ends up happening is I get an equivalent formula, for H. Whatever that side is, C, times the sine of A will always give me H. So what this is all saying on the right is saying, well, if I know that the formula is 1/2 base times height, they're saying, why don't we take what we just found the height can be and just plop that right in there. So this ends up being a formula that lets me get the area of a triangle even if I don't know the height of that triangle. So that's going to be the formula that's a little bit further down on your page. 1/2 the base times C sine of A. But that C sine of A thing is always going to be a way to get the height of the triangle. It's going to be equivalent. So if I know C and I know B and I know this angle A, I can figure out H, which means I can figure out the area of the triangle. So really, that's just a little bit about why it works. You just need to be able to use it, which actually goes pretty quickly. So I'll copy down the formula again for us here. We have 1/2 the base, and instead of height, we have C sine of A, but that equals the height of this triangle, right? So what do we have here? We have a side and an angle and a side. We know that we have a 48-degree angle. We have 21, which is the base of the triangle. We don't know the height of the triangle. So we would have to figure out the height in order to find the area of this triangle. But since we have this formula and we know this side C, we can, instead of finding the height and then plugging it in, we can just do it all in one step here. We can plug into this formula. So we have everything we need. 1/2, the base is 21, and then the height of the triangle would work like this. 12, the side they gave us, times the sine of the angle they gave us, 48. So this is just another way to find the height of a triangle, but they're just plugging it all into the area formula in one step. So we plug all that in, we get about 93.6 square centimeters. All right. I would recommend trying one on your own. On the video, we'll go over one more of these. I think it would be a good idea to pause and then resume after you've worked it all out. But you should be able to just plug everything in at this point. So I would pause now and resume when you are ready. All right, now that you've resumed, let's look at what we have. We have 1/2 BC sine of A. That C sine of A part is going to be what the height of the triangle is. So again, my problem is I don't know the height, but I do have the base. I do have another side length, and I have the angle in between those two side lengths that are given. So this is a side angle side formula. So what I can do is go right into the calculation step. B is 16. C they gave us as 10, and then the sine of 34, which is the angle that we knew this time. We can go straight to the formula and then get some calculator work going. We have about 44.7 square inches for the area of that triangle. So again, that works when you have side, angle, side instead of a height. If you have a height, then that's obviously going to be your best formula. All right, so that's bringing trig into some of our area stuff. That's going to do it for 10.5. At this point, you're ready to grab the homework and give that a go. All right, feel free to rewatch any problems that didn't make sense. Good job.